Hello dear learners, welcome again. In this video I am going to discuss very important topic of business economics, that is tools for economic analysis. Like any other subjects in economics, also we use different tools to see the relationship between variables, and we try to arrive at a conclusion, or we establish a theory with the help of these tools. So dear learners, if you find it useful, please like it, and if you have not subscribed my channel yet, please subscribe it. So let us begin with the topic, that is tools for economic analysis. So first of all, what for we do economic analysis? What is the aim of economic analysis? Right? So this aim of economic analysis, first of all, is to identify the economic variable. First of all, to identify the economic variable, then we try to see the relationship between the variables. Right? So what is this variable or economic variable? Or variable is something which varies or which changes. Similarly, economic variable is something which varies and which changes. So in economic analysis, we establish a relationship between variables, and we try to arrive at certain theory or proposition. Say for example, you are aware of a theory or a law called law of demand, like dx, demand for x is related with the variables. Say for example, price of x, price of related commodity y, income of the consumer, taste and preferences. So these are the variables which affects demand. So this is how the demand and variables of demand or determinants of demand are connected, right? So in economic analysis, economists try to use different tools. With the help of these tools, economists formulate theories, right? So what are those tools? They are functions, schedules, equations, graphs, diagrams, variables, lines, curves, slopes, identities, limits, derivatives, and so on. These are some of the important tools which are used in economics, right? Like we that in geography, if you are studying, you use maps as tools for understanding geography. Similarly, in economics, we use these tools, right? So in this video, I'm going to discuss these 5 highlighted one, mainly how and what they are. So let us see the first one, that is functions or functional relationship. A function explains the relationship between two or more economic variable. As I told you just now, the function is nothing but establishes a relationship between dependent and independent variable. Say again, I'll use the same example. Demand for x is function of price of x, price of any commodity z, or income and taste and preferences. So this is a functional relation. This is a function. dx is the function of px, pz, y, t. Here dx is demand, whereas px is price of x, pz is price of z, which is a related commodity, income of the consumer, and t is taste and preferences. So in functional relationship, we try to see the relationship between two and more variables. Here function shows relation between dependent and independent or other variables. So how we see what is dependent and what is independent variables. If you see here, D is the function of P, the simplest form, as law of demand says. Demand and price is inversely related. So D here is dependent variable. So D is dependent variable. Demand is dependent variable, whereas P, this price, is independent variable. Price is affecting demand. Demand is affected by price. So which is affected, that is dependent variable, and which is affecting, that is price, is independent variable, whereas this F is notation used for function. So this is, I think, this concept of dependent and independent variable is clear to you. If you have any doubt, you can comment in the comment box. Moving on to the next, that is types of function. The functions broadly may be classified into two: explicit function or implicit function. There is a basic difference between these two. In case of explicit function, you are able to identify which variable is dependent and which one is independent. Say for example, here you can see in this equation, y is equal to 4x minus 7. Here on the left hand side, this y is dependent variable, whereas this x is independent variable. Any change in x will bring in change in y, right? Similarly, this equation qx is equal to 200 minus 3p. This p is price, q is quantity demanded of x, and this minus sign shows that there is inverse relation between quantity demanded and price. So when price changes, demand also changes. So this qx is dependent variable, whereas p is independent variable. So in case of explicit function, you are able to easily make out which variable is dependent and which one is independent. Whereas in case of implicit function, the relationship between variables are not clear in terms of dependent and independent variable. In fact, they are interdependent values or interdependent variables. Say for example, x to the power 2 plus y to the power 2 is equal to 16. Here x and y both are interrelated, or x is affecting y, y is affecting x. So you are not able to make out which one is dependent and which one is independent. So in case of implicit function, it is not clear which is dependent and independent variable. Then moving on to the relation between the variables. The relation may be linear relation, the functional relation may be linear, or it may be non-linear. Let us understand with the help of a graph how linear and non-linear functions are depicted. So I'll show you with the help of a diagram. So let us draw. This is your y-axis, this is your x-axis. For the sake of example, I am taking consumption function. So consumption, simple linear consumption function is used as a plus by, where this a is intercept term. So this is intercept, that's why it is starting from here. This is origin, right? This is your y-axis and this is your x-axis. And you can see here, in case this is a straight line, right? This is a line, and in this the slope is constant. The change in x and change in y is having a constant pattern and constant value along this line. So in case of linear relation, the change is constant. Whatever change is happening, the percentage change is constant. Whereas in case of non-linear function, if you draw a diagram or a graph, you will not get a straight line. It will be a curved line. It will not be a straight line like this. Say for example, this is your total revenue, and in case of this, you can see on any point on this curve you will have different slope, unlike this linear function. So linear function where the change is constant, whereas along the nonlinear function it may be quadratic, it may be polynomial. You may have different types of function in case of nonlinear functional relationship. Okay, so this is the difference between linear and non-linear. In fact, a line or a curve is nothing but the locus of various points. A line depicts the relationship between the variables as it is depicted here. Like you see, on Y we have consumption and on X we have income. As income changes, consumption also changes. So a definite pattern is shown in this linear relation, right? So this is how the graphs are drawn, or functions are converted into linear and non-linear functions. So if you have any doubt here, you can comment in the comment box, dear learners. Moving on to the next thing, that is slope. A slope is very important while understanding this concept of graphs, right? For the student of economics, it is very important to learn what is slope. Slope is defined as the amount of change in the variable measured on y-axis to the per unit change in the variable measured on x-axis, and it is expressed in this form: delta y upon delta x, where this delta, this triangle, is change. For change we use this delta sign. So again I'll show you with the help of diagram that how this slope is measured, and for the sake of simplicity I am using again the same consumption line. You can see here we have consumption, y-axis we have consumption, on x we have income of the consumer. So this change, this is delta y along this horizontal line, and this along the vertical, that is y-axis, we have delta c. So this is the slope of this line. Again here you can make at this point you will measure, say for example like this, you can see the change. So this way you can write delta c upon delta y. So slope measures the change along the line, right? So and this is very important to see the change in one variable in relation to other variable. Moving on to the another important concept in economics, that is schedules. Schedule is a table, right, that shows the quantity of dependent variable in relation to an independent variable. For example, you can show with the help of demand schedule or supply schedule. Likewise, you can show. So schedule is nothing but a table. In this example, I have taken demand schedule for strawberry. You can see here price as independent variable, which is affecting amount of strawberry demanded, that is dependent variable. When price is 50, demand is 10 kg. When price increases to 75, the demand goes down to 9. And similarly, if say you can see the price has increased to 225 rupees per kg, demand has gone down to rupees 3 kilogram. So this is as per the law of demand. There, as price is rising, the demand for strawberry is going down. So this kind of a tabular presentation of this relationship functional relation between price and demand can be depicted with the help of schedules, and it makes it easy for the learners, for the student, and for the economist to show it in one image form. It becomes very easy to understand. That's why we show it in tabular form or in schedule form, and the same schedule then can be converted into graphical form. So graphs and diagrams. Graphs are also part and parcel of economics. In any branch of economics you will find, be it microeconomics, macroeconomics, international economics, or public finance, you will find graphs are widely used, because graphs show things in a clear form, and it becomes more understandable. The abstract ideas or theories can be shown with the help of a simple diagram. So a graph or a diagram presents relationship between two or more sets of data or variables that are related to one another. So use of graph provides a better understanding of economic generalization, like law of demand, inverse relation between price and quantity demanded. Then law of supply, direct relation between price and quantity supplied. So this can be depicted with the help of graphs, right? Say graph. So graph presents a visual picture of an abstract idea. If I can show you here, say law of demand, we have, like this. We can show this is a downward sloping demand curve you will have, right? Here we have price, here we have quantity. This is P1, this is your Q1, right? So when price goes down, say to P0, and quantity increases to Q2, like this. You see we can show the law of demand in this graphical form, right? So the economic generalization can be shown with the help of graphs. Moving on to the graph, usually they are drawn on a plain paper or a graph paper, and in a graph you have a horizontal line which is called as x-axis and a vertical line which is termed as y-axis, and this plane surface is divided into four parts which are called as quadrants, right? These four quadrants are numbered in anti-clockwise direction. So let us see how this quadrants are drawn. I'll show you here with the help of this x. You have, this is your y-axis, and this is y. This is your x-axis. So where the point where x and y are meeting, that is known as origin. This is the origin point, okay? And this quadrants are numbered starting from here. This is your first quadrant. In case of first quadrant, both value of x and y both will be positive, right? And it goes anti-clockwise or counter clockwise. This is your quadrant number 2. In case of quadrant number 2, value of y will be positive, whereas value of x will be negative. In case of quadrant number 3, you have both x and y values as negative, and this one is your quadrant 4. In quadrant 4, you have positive value of x. Whatever variable is depicted on x, that is positive, and the values which are depicted here is negative. So y will be negative and x will be positive. So if you quickly, I'll show you. This is positive, 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 negative, here negative, and this is also negative, right? This is negative and this is positive, okay? So usually in economics use this quadrant 1 more frequently, and at times we use this fourth quadrant as well. Say for example, I am drawing this saving line. This is a saving function. In case of saving, when the income is 0, here we have income. When income is 0, you have negative. The saving will be negative because you need something to consume, and that will be maybe borrowed money or from your wealth. So this is negative, and at this point you will have 0 saving, and after that your saving will go up. So like this, quadrants and the graphs are used to show abstract idea in pictorial form. Then moving on to diagrams. Diagrams are like graphs, and it is maybe shown in the form of pie chart, or maybe bar charts, or maybe circular flow of national income is also shown as a flow chart. And you can see here we have pie chart of sales data of anything. You can see this is quarter 1 sales, and this is quarter 2 sales, this is quarter 3 sales, and quarter 4 sales. You can see, easily make out in which quarter the sales was highest. You can say easily by looking at this pie chart that in the first quarter the sales was highest, and which quarter the sales was least. You can easily see it is the fourth quarter. So likewise, this diagrams are used to depict the abstract things in a easy form and in a pictorial form, right? Then moving on to the concept of equations. Equations are widely used in economics, in modern economics. Usually you will find, if you study mathematical economics or econometrics, you will find equations are widely used. And nowadays in marketing research and in research field, you will find in general estimation and for forecasting, you need to develop a model, and for modeling you have to convert the economic theory into equation forms. And these equations actually is nothing but conversion of verbal expression. This economic theory is verbal expression, a statement, and this statement is converted into the equations form, algebraic forms. So what is economic theory? Economic theory is it shows the relationship between variables, like law of demand. There is a relation between price and quantity demanded. So the same is converted into equation form, right? So the equations are very important, and it is used to calculate the value of unknown variable. Say for example, here I have taken again example of the consumption. C is equal to A plus PY, where C is consumption, A is autonomous consumption. Even if the income is 0, there will be some consumption, that is autonomous consumption. And then BY, this BY is induced consumption. B is marginal propensity to consume, which is estimated, which ranges from 0 to 1, whereas Y is income. So this is how equations are used in economics. So dear students, in economics, these are tools and techniques which are widely used to present the complex ideas, complex theories into pictorial form, algebraic form, equation forms with the help of graphs and the diagrams. You can make it more interesting, more understandable to the learners. Okay, so thank you so much. Thanks for watching. If you have still any doubt, you can comment in the comment box. Thanks.